Welcome in Tilco Advisors. We empower construction material manufacturers with cutting-edge digital solutions. And now, welcome to our podcast, where we share insights from the world of smart construction technologies.
The single best way to cut through the noise and get truly informed on the tectonic shifts reshaping global industry. Today, we are plunging deep into, an inescapable mandate facing manufacturers, supply chains, construction firms, really everyone worldwide, the Digital Product Passport, or DPP.
Yeah, and this isn't some far-off future concept. It's becoming regulatory reality fast, driven mainly by the EU's Eco-Design for Sustainable Products Regulation, that's the ESPR. The DPP looks set to be mandatory. We're talking by 2030, across huge sectors like textiles, electronics, vehicles, construction products. It demands this flawless, continuous digital record. Think about it from the moment raw materials are sourced right through to recycling or disposal, the whole life cycle.
And here's where the rubber meets the road for you, listening in and navigating these changes. This revolutionary new data system, it has to talk seamlessly and dynamically to the software platforms companies are already running. We mean integrating the DPP with often legacy, often siloed systems, things like building information modeling, BIM, product lifecycle management, PLM, and enterprise resource planning, your ERPs. This isn't just ticking a regulatory box, it's a massive industry-wide integration puzzle. It's rooted in some deep architectural challenges.
Exactly. So our mission today is really to analyze those core architectural challenges these systems present, and crucially, to reveal some working blueprints for actually achieving that integration. We need to figure out how to move past the old ways, the manual, static data exchanges, and get towards this dynamic, trustworthy, and this is key, bidirectional flow of information.
Okay, so if that's the regulatory mountain we need to climb, the integration headache, it really starts deep down in the architecture, doesn't it? Let's unpack this challenge.
Yeah.
And maybe we start by acknowledging a sobering fact our sources point out. Most developers listening, you're either working right now to maintain a legacy system, or you're busy creating a system that, let's be honest, will eventually become one.
That's just the reality of enterprise software, isn't it? These monolithic systems, the big PLMs, the SAP ERPs, they serve core business functions. You can't just rip them out. Modernization is always happening, sure, but the friction really appears the second you try to force these established, often siloed systems to meet the demands of something new, like the DPP.
Right.
Which needs constant external data sharing. It's a different paradigm.
And we see that friction really clearly in some of the, let's say, earliest, maybe most simplistic attempts to connect core systems, like ERP for finance and resources, with project tools like BIM. There was one construction case study we looked at, and it really highlighted what we're calling the static link problem.
What?
What exactly did they try there?
Well, they attempted integration by manually exporting a URL link straight out of the ERP system. This link supposedly contained all the material details, POs, schedules, everything. And then they just manually embedded that single URL into the properties of the corresponding 3D object right there in the BIM model. Seemed clever, perhaps. A quick fix.
Right. On paper, it sounds beautifully simple. Low effort, maybe. But why is that approach just a fundamental failure when you look at it through the lens of the Digital Product Passport?
Because it's completely static. And it only goes one way, unidirectional. I mean, imagine you're halfway through the project. The architect updates the BIM model, changes the quantity of some material. Or maybe procurement updates the ERP, new delivery date, supply chain issues, That embedded URL, it doesn't reflect those updates automatically. It's basically a dead record the moment something changes. So someone has to manually go back, re-export the link, re-embed it every single time. That manual step. It completely undermines the whole point of real-time, trustworthy, traceable data that the DPP demands.
And even if we zoom in just on the BIM and facility management sector, where data interoperability should be mature, we still see these persistent reliability challenges.
It's a chronic issue, isn't it? Models delivered at handover, end of construction, they often just lack the essential operational info owners actually need. Things like reliable warranty details, correct tech specs, or even just accurate links to maintenance systems.
And often it's not just about a poor handover process, it's compounded by a knowledge gap. The sources suggest that building owners themselves, they often lack the expertise to even define the specific asset information requirements, the AIR that they should be asking for. So if the client doesn't know what high-quality continuous data to specify in the first place, well, the information they get at the end is almost bound to be unreliable, or just not enough for actually running the facility long-term.
What's fascinating here, though, is that the DPP mandate, It requires more than just operational data. It demands granularity across the entire life cycle, right down to raw material sourcing, recycling instructions. Yes, this is the crucial leap. It raises the maturity bar, like significantly for product lifecycle management systems. Many existing PLM systems, especially maybe those used by SMEs, small and medium enterprises, they were designed for internal efficiency, maybe managing design changes. They weren't really built for continuous, granular external data sharing across a whole global supply chain. They're often just not mature enough, technically or process-wise, to support that level of detailed end-to-end data collection and constant updating that DPP compliance needs by 2030.
Okay, so if the old approach, the manual static link, is basically broken for dynamic records like the DPP, we need a better blueprint. Let's look at a solution that actually did overcome this unidirectional barrier, specifically in that BIM-to-FM space we mentioned, because it seems like it offers a really good architectural model for the dynamic flow the DPP requires.
Yeah, the core thinking behind this successful integration, the philosophy, was a conscious choice. Move away from proprietary software limitations. Embrace open standards. Because when you're locked into one specific BIM platform, every interaction needs expensive software, complex formats. It creates barriers. This BIM-FM solution, it created a working system really designed purely for interoperability, to stop information loss and ensure continuous updates.
Right, and it wasn't just one big program doing everything. It was an architecture, really. 4 components designed to integrate existing systems. Let's walk through those. First, they had to define the basics, the minimum common information requirements, based on standards, like ISO 19653.
Right, exactly. You need a common language, a standardized vocabulary first. So they figured out the essential, non-negotiable data points for every asset. Serial number, warranty info, location, things like that. But the second component is where the accessibility really kicks in. A web platform. Think of it as a central hub for registering, managing, auditing all that asset data.
And why is having that central platform so critical? What problem does it solve?
It solves the proprietary software bottleneck. It means people who aren't BIM experts, like, say, the technicians on site or maintenance contractors, they can update information. They can do it from any device, just using a simple web browser. They don't need access to some complex, maybe $4,000 BIM license just to log that piece of equipment past inspection or to update a warranty field. It democratizes the data update process.
Okay, makes sense. Then the third component is the digital plumbing, the communication bridge, the REST API. This is how the systems actually talk to each other securely.
Precisely. Think of the API representational state transfer API as the secure, standardized translator between these different systems. It makes sure that when the web platform needs to send an update, maybe to the BIM model, it speaks a common language, usually JSON format, which is widely understood. And to ensure only authorized systems are doing the talking, it uses secure methods. Token-based authentication, like JWT, is common. This creates that secure pipe, stops unauthorized access or data corruption.
Got it. And the fourth piece, you said this was crucial, the mechanism that actually ensures the data flows both ways, the Blender Bonsai add-on.
Yes, this add-on is really the technical proof that this dynamic model can work. It's the critical piece enabling data flow that isn't just one way. It can read open standard IFC files, that's the OpenDIM format, to initially populate the asset records in the web platform. But, and this is key, it can also go the other way. It can retrieve updated information from the API, maybe a change in maintenance history logged on the web platform, and automatically insert that updated data back into the original BIM model. And it puts it in the right place, allocating it correctly to the standard IFC attributes or specific property sets like set warranty.
Okay, so that's the essential takeaway here. It solves that chronic problem of data getting lost or becoming outdated after handover. By using open standards like IFC and a REST API, you ensure the original project model stays synchronized with the live operational management data throughout the entire life cycle. And crucially, it decouples the whole process from needing everyone to use the same expensive proprietary software. It's a working example, really, of dynamic DPP-style integration, just at the building asset level.
Absolutely. That ability to reliably write data back into the source model or system, that's the fundamental technical shift needed for something like DPP compliance.
Okay, so let's zoom out now. From that specific construction asset level example to the much bigger global supply chain challenge of the digital product passport itself. We need a strategic architecture that can handle full DPP PLM integration across potentially hundreds of manufacturers, suppliers, recyclers.
Yeah, we're definitely moving into a much more complex domain here, and partly because the DPP is deliberately based on a decentralized data system. This is a really important distinction. There isn't going to be one single massive central database somewhere holding every product passport in the world.
Okay, so if there's no giant central database, what takes its place? How does it work?
Well, you have a central unique identifier, UID registry. This will likely be managed by authorities like the European Commission. But this registry, it just acts like a public directory, essentially. It routes requests. So if you scan a product's QR code, the UID registry doesn't give you the data itself. It points you towards the manufacturer's own private system. That's known as a distributed repository. The key idea is the manufacturer maintains ownership and control over their sensitive data, their IP, within their own distributed repository.
Okay, but hang on. If every manufacturer, every supplier is maintaining their own repository, using their own mix of PLM, ERP, maybe document management systems, surely the data they produce must be a completely heterogeneous mess. Different formats, different languages, different units of measurement.
Exactly right. And that is why probably the most critical middleware component needed in this whole architecture is something called the transformation engine. You can think of it as the digital nexus, the central translator hub. It becomes absolutely mandatory because the data heterogeneity coming from all those different distributed repositories is just so massive.
So the transformation engine is essentially a huge standardized translator and data harmonizer.
Precisely. Its job is to collect data feeds from the manufacturer's PLM, maybe their supplier's ERP systems, their document management systems, perhaps even from recyclers later on, and translate all of it from all those different formats, units, languages. Maybe one supplier measures in meters and writes in German, another uses feet and English. The engine has to standardize that data immediately, flawlessly, into one common standardized format. Probably JSON again. That way, the data becomes comparable and actually usable by regulators or consumers or whoever scans the DPP. It ensures data trustworthiness despite the distributed sources.
Makes sense. So getting your own internal house in order so you can actually feed that engine reliable data, that seems absolutely key. Let's talk about the strategic roadmap then. Our sources outline sort of 6 steps companies really need to take to get their existing PLM systems ready for this seamless DPP integration. Where do they even start?
Well, the very first step is just internal honesty, really. Assess current PLM maturity and infrastructure. You absolutely have to conduct a detailed audit. Map the current state of your systems, the ASIs, and compare it against the advanced best-in-class state that DPP compliance is going to demand. You can't fix a problem you haven't accurately mapped out first.
Okay, step 1, assess. And step 2 sounds like it directly addresses that silo problem we talked about earlier.
It does. That's standardized PLM processes and data governance. This means getting serious about company-wide rules for data formats, naming conventions, and crucially, developing robust, standardized APIs for seamless data exchange between different business units or locations. These APIs, they need to use the correct HTTP methods, secure authentication protocols like OpenID or Auth 2.0 to make sure data sharing is continuous but also safe.
Step 3 feels a bit more proactive, looking beyond just the immediate technical fixes. Develop a sustainability and recycled material policy.
Yeah, it's essential. Companies really can't afford to wait until the final regulation details are published. They need to proactively align with the trends we're already seeing, things like mandatory recycled content in EU battery and vehicle regulations, and start vetting and finding suppliers who can provide compliant materials now. Sustainability data isn't just a report you file. It has to become a living part of the product's digital identity.
And then stepping up the game on how that data is actually collected in the first place. That's step 4, isn't it? Increase data granularity and improve traceability.
Absolutely. We need to move beyond just high-level product data towards collecting information at the component level. And this is where companies might need to start leveraging things like IoT devices for real-time information collection, maybe throughout the product's operational life. This ensures that the usage phase data, how long did the product actually last, how is it repaired, gets continuously fed back into that DPP record.
Step 5 sounds smart, kind of a classic project management approach. Pilot project.
Yes, definitely. Implement a trial integration first. Pick a less complex, lower-risk product to start with. This way, you gain real-world insights, you identify the true integration pain points, you deal with the inevitable technical hiccups, but without jeopardizing your core, highest-volume product lines. The lessons learned here are invaluable. Gold, really.
And then finally, step 6 is obvious once the pilot works. Scaling.
Right. Once that pilot provides the crucial insights and proves the concept, then you roll out the integration across all the relevant product segments. This kind of structured step-by-step approach is really the only viable way to achieve the huge organizational and technical maturity needed for full dynamic DPP implementation without, catastrophic business disruption.
So putting it all together from our deep dive today, the integration needed for the digital product passport, it fundamentally demands a pretty major strategic shift. We absolutely have to move away from those manually managed, static, one-way data transfers like that dead ERP link stuck in a BIM model, and move toward dynamic, programmatic, bidirectional synchronization, leveraging things like APIs and custom add-ons to make systems talk properly.
In this whole transformation, it really is underpinned by that strategic choice we mentioned, using open standards.
Yeah.
Things like IFC in construction, REST APIs, JSON for data exchange, because they are what ensure interoperability. They allow solutions to decouple from the constraints, the friction, the vendor lock-in of proprietary software, and that maintains the data integrity needed for this continuous information flow across the whole decentralized ecosystem.
What really stands out, though, is the kind of high-wire act the industry is being asked to perform here. The DPP system relies entirely on being decentralized, meaning manufacturers keep ownership and control over their sensitive data, their IP, in their own distributed repositories.
That's true. That's the design principle. But the universal success of this decentralized system, for regulators and consumers to actually trust the data they get from scanning a DPP, that hinges entirely on achieving a very high degree of standardization across every single economic operator globally.
So here's the real tension, isn't it? The thing that's going to drive innovation, and probably a lot of headaches in the coming decade. How can global industry successfully reconcile this absolute need for private distributed data storage, protecting sensitive IP, with the simultaneous regulatory demand for universally comparable, consistent, and utterly trusted product sustainability information? That reconciliation? Well, that's the ultimate integration challenge, perhaps. Something to think about.
That's it for today's episode. We hope you enjoyed exploring the world of smart construction and digital workflows with us. Don't forget to subscribe and join us next time for more insights into smarter construction.